Okay, so to get started with this in chemistry, like most physical science, it's really important to be able to make measurements and to use numbers to represent those measurements. And so what we're going to do is we're going to talk about some of the different ways that we do that. And in particular, what we're going to deal with is we're going to deal with something called scientific notation. So anytime you make a measurement, it is a quantity that has both a number and a unit. So for example, I'm 6 feet tall. 6 is the number, feet is the unit. If I said 6 meters tall, that means something completely different. Okay, that would be extraordinarily tall. And so that's what we're going to be dealing with it. But the thing is, in chemistry, a lot of the times we're going to be dealing with extremely large numbers or extremely small numbers. It's not going to be numbers like 6. I mean, that might happen, but it's going to be numbers that are got a lot of zeros, either between the last digit and the decimal point, and between the decimal point and the first digit. So depending on how big or small it is, we're going to have to deal with something called scientific notation. So scientific notation has some rules. The form of it, the way it's set up, is that you're only allowed to have one number, 1 through 9, to the left of a decimal. So you couldn't have a number like 1, 3, 5, 2. Okay, you're only allowed to have one number to the left of a decimal. That means I need to put the decimal right there. Okay, and then the next rule is that everything else, anything else that is considered to be significant, we'll talk about that later, is written to the right of the decimal. So the 3, 5, and 2 are on the other side of the decimal, to the right of the decimal. And then the way you make it the same magnitude, okay, this is to raise it to the same level. I mean, there's a difference between 1,352 and 1.352. If you think about that in terms of dollars, if I offered you $1,000 or $1, there's a big difference. And so dealing with the magnitude of it, you're going to take your number that's written in correct scientific notation and you're going to multiply it by 10 raised to the power of the original number. Well, this is 1,000, and 10 to the third power is 1,000. So that's an example of how it works. Sometimes instead of writing times 10 to the power, we write in E. And you'll see that particularly if you go to college at CU, they do that a lot. So the way to remember this is if the number, the original number, is greater than 1, then the exponent is positive. If the original number is between 0 and 1, then the exponent is negative. You're not going to have negative numbers. You might have negative exponents, but you will not have negative numbers. There's no negative mass or anything like that. So, some practice. We're going to practice writing these in correct scientific notation, but what I want you to look for is I want you to look at the number and determine, is it bigger than 1 or smaller than 1? That's all you need to be able to do. So this number, it's bigger than 1. That means I'm going to be multiplying times 10 to a positive exponent. So I'm going to put the decimal to the right of the first number as I read it. So 6.5. Okay, the zeros you can drop. They're not considered to be significant numbers. So 6.5. Now I need to have a multiplier in here to make the difference between 6.5 and 6,500. And that multiplier is 1,000, because 6.5 times 1,000 is 6,500. Well, 10 to the third power is 6,500, or 6.5 times that. So that is correct scientific notation. Now let me show you another way to figure it out. Take the decimal that is in the problem, and you know where it is. It's right there. It's not drawn, but you know that. And you want to move that decimal between the first two numbers as you read it. Right there. 6.5. And then you count how many times you moved it. 1, 2, 3. That becomes your power. And since it's greater than 1, it's positive 3. Okay? Let's do the same thing here. Again, you're going to move that decimal between the 3 and the 4. So you're going to have 3.45 times 10. Okay? And then count how many times you move it, because this is less than 1. You're going to have a negative exponent. 1, 2, 3, 4, 5. I had to move it 5 times, negative 5. Okay? Or you could write it as 3.45e negative 5. Either way is fine. Okay, so this one, it's greater than 1. That means I'm going to have a positive exponent. And just move the decimal. 1, 2, 3, 4, 5, 6. 5 times 10 to the 6th, or 5e to the 6th. Okay, and then this one is less than 1, so it's going to be, you're going to move the decimal 1, 2, 3, 4, 5, 6, 7 times 2.36 times 10 to the negative 7. It's negative because it's less than 1, and you put the decimal between the 2 and the 3. You do not move it all the way to the end. You move it between the 2 and the 3. There's only allowed to be one number in front of the decimal. Okay, so now going the other way, taking scientific notation and turning it into what's called standard notation, or normal notation, what you're used to seeing. So for this one, I'm looking at that and I say, all right, it's got to be less than 1 because it's got a negative exponent. So I'm dealing with 0 point. Okay, and so then I'm just going to count how many times I move that decimal point. I need to move it 7 times. 1 time moves around the 8. That means there's going to be 6 zeros between the 8 and the decimal point, and then 8, 4, 3. So just to check, I moved it 1, 2, 3, 4, 5, 6, 7 times. 1 time around the 8, and then 6 zeros to put it over there. Okay, now this one is greater than 1. So I'm going to move the decimal the other way. I'm going to have 8, 4, 3, and then a whole bunch of zeros. Because it's greater than 1, it's going to be, it's a positive exponent. So I'm going to have to move it twice around the 4 and the 3. That means I have to move it 5 more times around the zeros. And just to check and make sure, 1, 2, 3, 4, 5, 6, 7. Done. Go ahead and practice this last one here. Okay? See if you get the answer right. Pause the movie, whatever you need to do. And it's greater than 1. Alright, so the correct answer for this one is you're going to move the decimal 12 times. 1 time around the 9, because this is bigger than 1, so it's going to be 4, 9. And you have to move it 12 times. Well, I moved it once around the 9. That means I need 11 zeros. If you want to put in commas, oops, put it in the wrong spot. Sometimes that helps, but that's basically the idea. Okay, now this one's a little tricky. It's not positive and it's not negative. It's 0. How many times am I moving the decimal point? Well, I'm moving it 0 times. 7.1. Done. Okay, so I want you guys to go ahead and practice. We're going to turn all of these numbers, write them down in your notes. I think there's one more. Yep. Write them down in your notes and turn them into correct scientific notation. So pause the movie, write them down, see if you can come up with the correct answers. I'll put the correct answers up in a second. Alright, so for this one, you're going to move that decimal from here to between the 6 and the 3. So 6.3501. You have to include all the numbers, not all those extra zeros, but at least all those numbers. So there's a decimal between the 6 and the 3, and you moved it 3, 6, 9, 10 times. Right? 3, 6, 9, 12 times. Sorry, can't count. Didn't think 10 sounded right. Alright, this one is less than 1. So you're going to move that decimal between the 7 and the 0. And I'm going to use e's now. And I moved it 1, 2, 3, 4, 5 times. Negative 5. Okay, this one's a little trickier. Okay, this is greater than 1 because of that 2. So basically I'm taking this and I'm moving that decimal point 2 times. So 2, 5, 2, 3, 0. But that's not correct scientific notation. So I think it's easier to turn it into a normal number first and then turn it into correct scientific notation. And so when I move that decimal all the way over between the 2 and the 5 at the beginning, because remember there can only be a 1 number to the left of the decimal, you get 2.523 e to the 4th, because I had to move it 4 times. This one's less than 1. Put the decimal there, 3.2075 e to the negative 1, 2, 3, 4, 5, 6. Is that right? 3, 6. Yep. Negative 6. And then the last one's greater than 1, 8.64 e 368 to the 8. Alright, now go ahead. We're going to do the same thing here. I want you guys to practice. Turn these all into normal numbers. Okay, so pause the movie, write them down, whatever, and turn them all into normal numbers, and I'll put the correct answers up in a second. Okay, so for this one, you're going to move the decimal, it's greater than 1. You're going to move the decimal 3 times around those numbers, so that means it's going to be 4, 3, 5, 2, followed by 11 zeros. Okay, I had to move it 14 times. This one's much less than 1. I'm going to move it 20 times, but 1 time is around the 8, so that means between the 0 and the decimal and that 8, there has to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 zeros. 8, 9, 9, 0, 3. You can see why this is preferred. It's kind of a pain in the neck. This one again, less than 1, 0 point, and there's going to be 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2, 5, 4. This one's a little tricky. It's still greater than 1, and you're going to move the decimal 2 times this way. So 4, 2, 7, 0. And then the last one, again, you're not moving it anywhere. 1.7. Done. Okay, now using your calculator. So you need to have a scientific calculator in chemistry. There is just no ways around it. And do not type in multiply 10 and the little caret thing. Okay, it doesn't always work. It works a lot of the time, and that's why it gets confusing. And some calculators will work all the time. But the best way to do it is to use this double E button, or I think on the Casios it's something else. But basically, you want the scientific notation button. You don't want the times 10 raised to. And let me just give you an example. And it will work for some people and it won't work for others. So we're going to practice doing these problems, and I want you to type them in as they are. So on a regular calculator, or whatever calculator you've got, type in 8 times and then the number 10, 110, and then do this little caret button and then put in the 2. And then add 4 times 10 and do the little caret 2. And what you're doing, just so you know, is you're taking 800, which is this number, and you're adding 400. So your calculator should say 1200, or 1.2 e to the third. Okay? And probably most calculators will do that. When you do this one, same thing. I want you to compare this versus the double E button. That is going to be 800 minus 400, so your calculator should say 400, or 4e2. And most calculators will do that as well. But if you do this one, it may not work the way you expect. So 8 times 10 caret 2 times 4 times 10 caret 2. That is 800 times 400, which is 320,000, something like that. So you want to make sure that your calculator comes up with that, and compare doing a double E button versus the 10 raised to the power button. But here is where the error comes in. 800 divided by 400 is 2. Okay, that's just, we know that. Okay, if you do it using this times 10 raised to, your calculator probably won't say 2. It'll probably say 2e to the 4. Okay, it will work if you do that. So your calculator should say 2 when you do that. And so the best plan is to just get in the habit and always use that button, because, you know, 800 divided by 400 is not 2,000 or 20,000, whatever your calculator says. So just, that's the best idea, is to take the time, use that button, make it a habit. Don't do this. Okay, and I will come around and assist you with your calculators in class to make sure that you know how to use them properly.